In a shooting facility outside Chengdu on September 14, 1986, a pistol that looked almost identical to the sleek Smith & Wesson Model 59 fired a magazine at a human-sized target just 25 meters away and missed entirely, with rounds scattering across a 2-meter circle around the intended point of impact. As the test officer fired again with the same wildly inconsistent results, Chief Engineer Liang Deming watched in disbelief through binoculars as bullets struck everywhere except the target, realizing that 9 months of intensive reverse engineering had produced a weapon so inaccurate it couldn't reliably hit a man-sized target at pistol combat range. The weapon, China's attempt to copy one of America's most popular police and military sidearms, had failed not through mechanical malfunction, but through something far more insidious: barrel and slide manufacturing so imprecise that the gun's accuracy was worse than weapons produced a century earlier. This is the story of how China discovered that a modern pistol's accuracy depends on tolerances measured in thousandths of an inch, and that copying external appearance cannot replicate the precision manufacturing that makes a weapon shoot straight.
The pistol that modernized law enforcement. The Smith & Wesson Model 59 represented a significant evolution in American handgun design when it was introduced in 1971. As Smith & Wesson's first mass-produced, double-action, high-capacity 9mm semi-automatic pistol, it combined several features that law enforcement and military users had been requesting: a 14-round magazine capacity, more than double that of traditional revolvers or single-stack pistols, a double-action trigger mechanism that allowed safe carry with a round chambered, and the widespread 9x19mm parabellum cartridge that was becoming the international standard. The Model 59 was based on the earlier Model 39, which had been developed in the 1950s and saw limited military use, but incorporated a double-stack magazine design that increased capacity dramatically while maintaining reasonable grip dimensions. The pistol featured an aluminum alloy frame to keep weight manageable despite its larger size, a steel slide and barrel, and Smith & Wesson's reputation for quality and reliability. What made the Model 59 particularly successful was not revolutionary technology, but excellent execution of established principles. The pistol was accurate, capable of 2 to 3-inch groups at 25 yards in competent hands, which was excellent for a service pistol. This accuracy came from precise barrel fitting, tight slide-to-frame lockup, consistent trigger mechanism, and quality manufacturing throughout. The barrel lockup was particularly sophisticated. Unlike simpler blowback pistols where the barrel remains fixed, the Model 59 used a modified Browning-style tilting barrel system. During firing, the barrel and slide were locked together and recoiled rearward for approximately 3/8 inch. The barrel then tilted down to unlock from the slide, with the slide continuing rearward to extract and eject the spent case while the barrel stopped against the frame. This locking system ensured that the barrel and slide were solidly locked together during the critical moment of firing, which was essential for accuracy. The barrel's fit within the slide was critical. The barrel had to move smoothly during the locking and unlocking cycle, but couldn't have excessive play when locked. Any looseness would allow the barrel to shift position slightly during firing, degrading accuracy. Smith & Wesson achieved the right balance through precision manufacturing and careful fitting during assembly. The slide-to-frame fit was equally important. The slide rode on rails machined into the aluminum frame, and these rails had to be precisely positioned and dimensioned to ensure the slide reciprocated smoothly without excessive play. Too tight, and the slide would bind, causing reliability problems. Too loose, and accuracy would suffer as the barrel's position relative to the sights would vary from shot to shot. By the mid-1980s, the Model 59 had become one of the most widely issued police sidearms in the United States and had been adopted by several military special operations units. Its reliability and accuracy had been proven through millions of rounds fired in training and actual use. The pistol represented mature American firearms manufacturing, not cutting-edge technology, but excellent execution of proven designs using quality materials and precise manufacturing. For Chinese law enforcement and military officials in the mid-1980s, the Model 59 represented an attractive modernization opportunity. Chinese police and security forces were still equipped primarily with revolvers and older semi-automatic pistols, many dating to the 1950s or captured from various sources over the years. A modern, high-capacity 9mm pistol would provide significant capability improvements, more rounds between reloads, faster reloading with magazines versus loose cartridges in revolvers, and the widespread availability of 9mm ammunition that China already manufactured for submachine guns.
The project's optimistic beginning. The project to reverse engineer the Model 59 was initiated in January 1986 at Factory 208 in Chengdu, a facility that specialized in small arms production since the 1960s. The factory's director was Yang Zhenhua, a 51-year-old administrator who had risen through the factory management ranks. His technical knowledge was limited, but he was an effective manager who understood how to navigate China's industrial and political bureaucracies. The technical lead was assigned to Chief Engineer Liang Deming, a 40-year-old firearms designer who had graduated from the Beijing Institute of Technology in 1970. Liang had worked on various pistol projects throughout his career, primarily involving modifications and improvements to existing Chinese designs. He was experienced with pistol mechanisms, but had limited exposure to the manufacturing precision required for truly accurate handguns. When Director Yang showed Liang the 3 Smith & Wesson Model 59 pistols that would serve as the basis for reverse engineering, 2 obtained through Hong Kong commercial channels, and 1 captured from a criminal gang, Liang felt confident about the project. The Model 59 looked straightforward, a conventional tilting-barrel semi-automatic pistol without exotic features or obviously complex mechanisms. "This appears to be a manageable project," Liang told Yang during their initial meeting. "The operating principle is well established, the mechanism is not particularly complex. American pistols are generally less sophisticated than European designs, like the Walther P38 or SIG P210. I estimate we can have functional prototypes within 6 months and begin production within 12 months. Yang was pleased. "Excellent. The Ministry of Public Security wants to begin equipping police units with modern pistols. This project has high visibility. Success will benefit the factory and everyone involved." What Liang didn't fully appreciate was that the Model 59's apparent simplicity concealed demanding manufacturing requirements. The pistol's accuracy depended on precision that Factory 208's aging equipment and inconsistent processes might not achieve. The hidden precision. Liang assembled a team of 8 engineers and technicians to work on the project. His deputy was Zhou Xiaoping, a 33-year-old mechanical engineer with strong analytical skills. The team also included Hu Jiming, the factory's metallurgist, master gunsmith Tong Shiji, who possessed decades of practical experience, and various specialists in machining, heat treatment, and assembly. The team began with complete disassembly and documentation of all 3 Model 59 pistols. They measured every dimension, photographed every component, created detailed technical drawings, and analyzed the materials. This documentation phase consumed 6 weeks and revealed increasing complexity. The barrel appeared simple, a 4-inch steel tube with rifling and a chamber. But Zhou's detailed measurements revealed sophisticated geometry. The exterior had a locking lug that engaged the slide during firing, positioned and dimensioned with precision. The chamber was precisely reamed to specific dimensions that ensured reliable feeding and safe firing.
The crown, the area at the muzzle where the bullet exits, was carefully cut at an angle that protected the rifling from damage and ensured the bullet departed concentrically. The barrel straightness is critical, Zhou reported during a technical review in February 1986. I've measured it with our best equipment, and over the 4-inch length, deviation from perfect straightness is less than 0.001 inches, about 25 micrometers. The bore diameter is held to within 0.0005 inches across the length. The rifling groove depth is uniform within 0.002 inches. These are very tight tolerances. The slide presented its own challenges. Machined from a steel forging, it had to be precisely dimensioned to fit the frame rails with minimal play while still reciprocating smoothly. The interior had to precisely accommodate the barrel during its locking and unlocking cycle. The breech face, the surface against which the cartridge base rested during firing, had to be perpendicular to the bore axis within minutes of arc. The frame was manufactured from aluminum alloy, which provided light weight but required careful machining. The frame rails that guided the slide had to be precisely positioned, parallel, and straight. The barrel lug seating area had to be accurately positioned and dimensioned. Any imprecision in the frame would cause accuracy problems that no amount of barrel quality could overcome. Hu, the metallurgist, analyzed the materials. The barrel appeared to be made from 4140 chrome molybdenum steel, properly heat-treated to approximately 38 to 40 Rockwell C hardness. The slide was similar steel, perhaps slightly harder. The aluminum frame was a 6000 series alloy, probably 6061, heat-treated to T6 condition for optimal strength. We can approximate these materials, Hu told Liang, but our heat treatment control is less precise than American processes. We may see more variation in hardness and strength between components. The aluminum frame will be particularly challenging. Our aluminum mills have less experience with 6000 series alloys, and the heat treatment requires careful control. The trigger mechanism was relatively straightforward mechanically, but achieving a clean, consistent trigger pull required precise geometry in the engagement surfaces and careful spring selection. The double-action pull had to be heavy enough for safety, but not so heavy that accurate shooting was impossible. The single-action pull had to be light and crisp, with minimal over-travel.
Manufacturing compromises. By March 1986, Liang had developed a manufacturing plan. Barrels would be manufactured from steel supplied by the Chongqing Steelworks, using Factory 208's existing rifling and chambering equipment. Slides would be forged at an outside facility and then machined in-house. Frames would be machined from aluminum forgings. Components would be heat-treated in the factory's furnaces and assembled by skilled technicians. The plan assumed that Factory 208's equipment could hold the required tolerances. This assumption would prove overly optimistic. The steel arrived from Chongqing in April, and quality issues were immediately apparent. The steel composition varied between batches. Carbon content ranged from 0.38% to 0.44%, when consistency within 0.03% would have been desirable. The steel also contained more impurities than American gun barrel steel, which could create weak spots and affect heat treatment results. Master gunsmith Tang was assigned to manufacture the first barrel. Tang was 59 years old, one of Factory 208's most experienced craftsmen, trained in traditional gunsmithing methods and possessing exceptional hand skills. He understood that barrel quality would determine whether the Chinese pistol could match American accuracy. Tang worked carefully for 3 weeks on the first barrel, but Factory 208's equipment imposed limitations. The lathe used for turning the barrel exterior had worn ways that introduced slight wobbles. The deep hole drilling for the bore was less precise than ideal, creating a bore that wasn't perfectly straight.
Deviation was approximately 0.003 inches over the barrel length, triple the American specification. The rifling machine, vintage 1960s Soviet design, cut grooves that varied slightly in depth along the barrel's length. "This barrel is adequate for functioning," Tang told Liang after completion, "but it won't match American accuracy. The bore straightness is marginal. The rifling uniformity could be better. An experienced shooter might notice accuracy degradation, especially beyond 15 meters." The slide manufacturing encountered similar problems. The forging arrived from the outside supplier with dimensional variations that required excessive material removal during machining. The factory's milling machines, worn from decades of use, couldn't consistently hold the required tolerances. The slide's internal surfaces, where the barrel locked during firing, were rougher and less precisely dimensioned than American specifications. The aluminum frame manufacturing was particularly problematic. Factory 208 had limited experience with aluminum machining, which requires different cutting tools, speeds, and techniques than steel. The aluminum forgings from the supplier varied in properties, suggesting inconsistent heat treatment. The frame rails, critical for accuracy, were machined on equipment designed for steel, producing surfaces that were less precise than required. By June 1986, components had been manufactured to assemble the first prototype. Designated the Type 86 internally, it superficially resembled the Model 59, but revealed compromises upon examination. The barrel showed visible tool marks. The slide to frame fit had noticeable play. The slide could move laterally about 0.008 inches when the pistol was in battery, compared to less than 0.002 inches in the American original. Various components required hand fitting to function properly.
The accuracy disaster. The first test firing was scheduled for July 1986 at Factory 208's indoor testing range. Liang brought his engineering team, along with Director Yang and several officials from the Ministry of Public Security who had traveled from Beijing to observe this milestone. The test shooter was Officer Zhu Yongchong, an experienced pistol marksman from the Chengdu Police Department with competition shooting experience. They had 200 rounds of Chinese-manufactured 9mm ammunition for testing. Zhu loaded a 14-round magazine. The Chinese-manufactured magazines fit loosely but functionally, chambered around, and aimed at a target 10 meters distant. He fired carefully in single-action mode, focusing on trigger control and sight alignment. The pistol discharged and cycled properly, ejecting the spent case and chambering the next round. He fired a 5-round group, then examined the target through a spotting scope. The group measured approximately 6 inches, far larger than the 2 inches that the American Model 59 typically produced at this range. More concerning, the group wasn't centered on the point of aim. It was offset approximately 4 inches to the right and 3 inches low. "The accuracy is poor," Zhu reported, lowering the spotting scope. "The group size suggests the pistol has fundamental accuracy problems, barrel quality, lockup issues, or both. The point of impact offset suggests the sights aren't properly aligned with the bore, but that's relatively easy to correct. The group size is the serious problem." They adjusted the sights and continued testing at 10 meters. The groups remained large, typically 5 to 7 inches for 5-round groups, making the pistol barely adequate for close-range defensive shooting. At 15 meters, the accuracy deteriorated further. Groups expanded to 8 to 10 inches. At 25 meters, the standard distance for pistol accuracy evaluation, the groups were catastrophic. Officer Zhu, who regularly shot 4-inch groups at this distance with quality pistols, produced groups measuring 15 to 18 inches with the Chinese prototype. "This is completely unacceptable," Zhu said bluntly. "At 25 meters, this pistol is barely accurate enough to reliably hit a human torso. For police use, where we need to be able to engage threats at distances up to 20 or even 30 meters, this accuracy is inadequate. An officer could fire at a criminal and miss entirely, endangering bystanders." Liang took the pistol and examined it carefully. The barrel-to-slide lockup felt loose. He could detect slight movement of the barrel when the slide was in battery. The slide-to-frame fit had obvious play. When he looked through the bore with the slide removed, he could see that the bore wasn't perfectly straight. It showed a slight curve. Multiple factors are degrading accuracy, Liang told his team. The barrel straightness is marginal. The barrel lockup has too much play. The slide-to-frame fit is too loose. The riffling may be contributing dispersion. We need to address all these issues.
Months of marginal improvement. The period from August through December 1986 involved building and testing 6 more prototypes, each attempting to improve accuracy through better manufacturing. The improvements were marginal and inconsistent. The second prototype used a barrel that Tang had manufactured with extraordinary care, taking 5 weeks and using every trick he knew to maximize straightness and rifling uniformity. This barrel showed better accuracy. Groups at 25 meters averaged 12 inches instead of 18, but this was still far worse than American performance. And critically, the time and skill required couldn't be replicated in production. The third prototype incorporated tighter slide-to-frame tolerances, achieved through careful hand fitting by Tang. Accuracy improved slightly, but the tighter fit caused reliability problems. The slide would occasionally bind during cycling, especially when the pistol was dirty or inadequately lubricated. The fourth prototype attempted to improve barrel lockup through modified locking surfaces. This helped somewhat, reducing play during firing, but accuracy remained disappointing. 10-inch groups at 25 meters, still triple American performance. The fifth and sixth prototypes explored different approaches, varying steel compositions, modified heat treatments, different rifling techniques, alternative frame materials. Some approaches produced modest improvements, others were neutral or negative. None achieved breakthrough results. The fundamental problem was that accuracy depended on precision across many interdependent factors. The bore had to be straight, the rifling had to be uniform, the chamber had to be concentric with the bore, the barrel had to lock solidly in the same position for each shot, the slide had to reciprocate without shifting laterally, the frame had to provide a stable platform. Factory 208 couldn't consistently control all these factors to the tolerances required for good accuracy. We can manufacture pistols that function reliably, Liang told Director Yang during a progress review in December 1986. They feed, fire, extract, and eject consistently. But achieving accuracy equivalent to the American Model 59 requires manufacturing precision that exceeds our current capabilities. Our machine tools are worn and can't hold tight tolerances. Our steel quality varies. Our heat treatment isn't consistent. Even our best craftsmen, working with maximum care, can only approach American accuracy, not match it. Yang was frustrated. The project is nearly a year old. Beijing is asking questions. We cannot simply report that Chinese factories cannot match American pistol accuracy. That would be politically unacceptable. The demonstration failure. In January 1987, under pressure from Beijing to demonstrate progress, Factory 208 organized a demonstration for senior officials from the Ministry of Public Security and the People's Liberation Army. The demonstration would compare the Chinese Type 86 pistol against the captured American Model 59 pistols, showing that Chinese manufacturing could produce equivalent weapons. The demonstration was scheduled for January 23, 1987, at a police firing range in Chengdu. Attendees included vice ministers from public security, senior military officers, provincial officials, and media representatives who would document Chinese achievement in modern weapons manufacturing. 2 shooters would participate, Officer Su representing the Chinese side and Officer Chen from the Beijing police representing neutral evaluation. Both were experienced competition-level pistol shots. They would fire from 25 meters at standard targets, with 5-round groups fired from both the Chinese and American pistols. The demonstration began with Officer Chen firing the American Model 59. He fired carefully, using proper stance and technique. His first 5-round group measured 2.8 inches, typical excellent performance for a quality service pistol. His second group measured 3.1 inches. The results were consistent and impressive. Officer Su then fired the Chinese Type 86 pistol, the best prototype Factory 208 had produced, using a barrel from Master Tang's most careful work. Su fired equally carefully, concentrating on technique. His first group measured 9.4 inches, over 3 times the dispersion of the American pistol. His second group measured 11.2 inches. One round missed the target entirely, impacting 2 meters to the side. The silence from the assembled officials was profound. The comparison was devastating. The American pistol had demonstrated precision suitable for law enforcement and military service. The Chinese copy had demonstrated accuracy barely adequate for close-range emergency use. Director Yang attempted to explain. The project was developmental. Further improvements were planned. The results would improve with additional development time. But the visual evidence was undeniable. The targets hung side by side told a story that no amount of explanation could change. Chinese manufacturing couldn't yet replicate American precision in pistol manufacturing. The media representatives were quietly instructed not to publish anything about the demonstration. The visiting officials left with polite expressions of encouragement, but clear understanding that the Type 86 was not ready for adoption. The project's political support evaporated.
Termination and lessons. The Type 86 project was quietly terminated in March 1987. No formal cancellation was announced. The project simply stopped receiving funding and priority, with resources reallocated to less ambitious efforts. Factory 208 returned to manufacturing existing pistol designs that, while dated, were at least adequately accurate. Liang Demeng continued working at Factory 208 until his retirement in 2004, but he never again led major new development projects. The Model 59 failure became an informal case study within Chinese weapons design circles, an example of how reverse engineering requires not just copying form, but replicating precision. We looked at the Model 59 and saw a simple pistol, Liang reflected in a 2003 interview with engineering students. We should have seen the entire American manufacturing system that produced it, the precision machine tools capable of holding tolerances within thousandths of an inch, the quality steel mills producing consistent materials, the heat treatment processes carefully controlled to achieve exact properties, the skilled workforce trained to exacting standards, the quality control systems ensuring every pistol met specifications. You cannot copy a precision product without precision manufacturing capability. The failure taught important lessons about the relationship between accuracy and manufacturing precision in firearms. A pistol must return to exactly the same configuration for each shot, the barrel in the same position, the slide locked identically, everything aligned consistently. Achieving this requires tolerances tighter than might seem necessary. A few thousandths of an inch of extra clearance seems trivial, but at 25 meters it translates to inches of dispersion. At 50 meters it becomes feet. Chinese pistol manufacturing gradually improved through the 1990s and 2000s, not through copying foreign designs, but through systematic industrial upgrading. Newer machine tools with better precision, improved materials with tighter quality control, better heat treatment equipment and procedures, enhanced training for workers and engineers. By the 2010s, Chinese manufactured pistols showed accuracy approaching international standards, but this came from industrial development rather than reverse engineering. The Smith & Wesson Model 59 itself was eventually superseded by third-generation Smith & Wesson pistols and then by polymer frame designs from Glock and other manufacturers. But during its production run from 1971 to 1982, over 300,000 were manufactured, and the design influenced subsequent high-capacity 9mm pistols worldwide. Its accuracy and reliability came not from revolutionary features, but from manufacturing excellence, quality materials, precision machining, careful assembly, and rigorous testing. The failed Type 86 prototypes were eventually destroyed, except for one carefully preserved as a teaching example at the Beijing Institute of Technology. Engineering students examine it alongside one of the captured Model 59 pistols, comparing the machining quality, measuring the differences in tolerances, understanding how small variations in manufacturing precision translate to large differences in accuracy. The lesson is displayed on a placard beside the pistols. Quote, "Precision cannot be approximated, accuracy cannot be copied, manufacturing quality cannot be wished into existence. These attributes must be earned through systematic development of industrial capabilities, one improvement at a time, over years or decades. There are no shortcuts." That lesson, learned at the cost of a year's wasted effort and damaged professional reputations, remains relevant for any nation attempting to close technological gaps through reverse engineering. The gap between appearance and performance, between copying form and replicating function, cannot be bridged simply by making something that looks similar. The performance comes from the precision, and precision comes from industrial maturity that takes generations to build.